Hello, I am Trent Rosenthal, the founder and CEO of Qubibyte. Today I'm going to be showing you a little bit of a demonstration about the Qubibyte Quadra, which is the NMR quantum computer that we're working on. So typically when you think of a quantum computer, you may think of one of those kind of huge machines that you'll see at like IBM or Rigetti that are cooled to pretty much absolute zero. They cost millions of dollars. That's not at all what we're working on. We're working on sort of a much smaller system that can be owned by pretty much anyone, so like universities or researchers. It's very affordable. It looks like it will cost about $800. And here's a little bit of the inside of it. So we have a sample tube, which contains the qubits, which are the basic units of information in quantum computing. And that can be a few different things. Right now we have water put into here. It can be a few other things. So water is 1 qubit. There's a few other things that can make it up to 4. But overall, there's a few different samples you can choose. And around that sample tube is a coil, a transceiver coil, which can send different operations, different signals to this sample to perform different quantum algorithms. And outside of all of this is a pretty big setup of magnets which provide an external magnetic field, and that takes advantage of a property called intrinsic angular momentum within the molecules in the sample. So that's also known as spin. That spin will align with the external magnetic field, and this transceiver coil, the whole job is to sort of knock that spin out of alignment. And you can see it here. So if this is the left side, this is one of the magnets, this is the other. The spin is lined up with that magnetic field, and when you apply a pulse from the transceiver coil, that spin will get knocked off into the transversal plane, and then it will actually start rotating or start precessing around the external magnetic field, and eventually it would work its way all the way back up to alignment. But this whole process of precessing produces a signal called free induction decay, which we can actually measure, and it's a little bit hard to explain without like a whole quantum course, but pretty much what we can get from the information here is enough to, if I build a circuit here on our quantum circuit simulator and run this circuit, it's enough to produce a result such as this one, which this is Grover's algorithm. It's sorts a unsorted. It finds the key of an unsorted database with a much bigger speed up than you would with just a normal classical algorithm. But through quantum, you can find it much faster. We can do this through the NMR quantum computer, and you can find this result here, which is actually pretty useful. And there's a pretty big amount of quantum algorithms that you can use to get pretty useful results. So that's what Qubibyte Quadra aims to do.